In this video, I will be showing you how to build your own custom natural language processing chatbot using Python. It will be very simple chatbot, but the purpose of this video is show you how the AI chatbots see the words and how the algorithms behind them generate answers. Together we can make history. Let's dive in. I will give you a quick demo how the final chatbot will look like. So this is the code, don't worry about it. These will be the sentences from which the chatbot will learn. And to the last method of our chatbot, generate sentences, you will put the length of your required sentence and it will generate a sentence from the words from the training data. Let me run the code and you see, dogs are usually dogs. Very good sentence. Now you have a basic idea what we will build today, so without further ado, let's go to the code. Let me start with the code. Our chatbot will be represented by one class. I will call this class Ultra Word Machine. Like this. Like every class in Python, it needs to have a constructor. You can define constructor by define init and the self parameter, the instance itself. Okay, here I will define three things. Self dot word dictionary will be empty in the start. The self is the instance word dictionary. I think you got it. Here in the word dictionary there will be all the unique words from our training set. The next dictionary will be self word dictionary preceding words. It will be empty from the beginning also. And what does it mean? It will be set of words before a certain word from our dictionary. The third and the last attribute of our class and our instances will be word dictionary following word. As with the preceding words, the following words will contain a set of words after a certain word. The first method will be process sentences. Okay. Process sentences. The argument will be the instance itself and the training set sentences. Here I will initialize a variable that will determine the order of our words in a dictionary. The default value will be 0, and for sentences in our training dataset, these sentences I will split into words with the sentence. I will iterate one sentence at a time, and this one sentence I will split into the words by the built-in function split. This function will create a list of words. The default value for split is empty space. For word in that sentence split into words, if that word in lowercase is not in, like this, not in, here I am missing colon, not in self word dictionary, like another colon missing, I will add that word in lowercase into the self word dictionary. Self word dictionary. The key will be the word in the lowercase, and the value will be the y, which will determine the order of our words. And I will increment the y by 1. Here I will print the dictionary. word dictionary. Run the code, and it doesn't work. I know why this is not working, because I haven't called anything. I need to create the instance of that class. I will call it Chat GPT-6, and it will be instance of ultra word machine. No arguments are needed, and I will call a method of this instance. ChatGPT-6 that process sentences, and I will put here the sentences from our training set. Run the code. Here, as you can see, it processed the sentences, and now we have a dictionary. Our ChatGPT-6 knows 12 words. That's not much, but it is honest work. You know what I mean. As the next thing, we will create the second dictionary, word dictionary preceding words. It will contain a word from our dictionary and the words that have occurred before that certain word. The next will be the following words, and with these three dictionaries, our chatbot will be able to generate a sentence. So, define another method. I will call it create dictionary with preceding words. Here I will put self and the training set. I will initialize the last word to be nothing from the beginning. This variable will serve us as a storage for the word before our word. I will start the same as in the last method for sentence in sentences. Sentence. Split into words. Sentence. Split. And here is a little change for index. We need index this time. Word in enumerate. Sentence split into words. The enumerate function help us to enumerate through this list. It won't give us only the word one by one, but also the index that correspond to the word. Colon if word but lower not in sentence split into words. I will add it to the word dictionary with preceding words. The key will be the word in lower, and I will create a set there. Now, what's the next step? After this if statement, the word will be in our preceding words dictionary. So we need to differentiate between if it is the first word and there is nothing before it, and if it's the other word. If the index is equal to 0, it will be the first word. In this case, I will add to the self-word dictionary preceding words, where the word in this iteration will be, we will find the word from this iteration in the dictionary. If it wasn't there, we edit the word to the dictionary, so now it's 100% there, and I will add, so before the first word is nothing, I will add here like this sign, this symbol. Now for the next iteration, I will store the word into the last word in lowercase, and else, if it's not the first word, I will tell preceding words. The key will be also the word in lowercase, and I will add the last word from the last iteration into the set of the preceding words. Here, the last word will be equal to word in lowercase, again, for the next iteration. Here, I will print the self preceding dictionary. ChatGPT-4, call the method, create dictionary here, put the training set, enter, run the code. We have a mistake here. Yeah, I think I see the mistake. If the word not in tells that if the word is not in the dictionary, like here, not in the split sentences. It should be okay right now. As you can see, the I is only in the beginning of the sentences, and for example dogs, before dogs there is like nothing because it is in the beginning, or it is end, or the last one is low. The low is here, okay? You see, that's for the older words from our dictionary, and now it's time for the following dictionary words. Creating following words dictionary is pretty similar. I will define create dictionary following, I'll close this, following words. Here I will put the self, sentences, and I don't need the last word this time, so only the for instance. I will create this dictionary through the indexes. So for instance, for sentence in our training set, I will split these sentences like this sentence, split into words, sentences, no, sentence, split here for index, word in enumerate, sentences split to words, sentence split words, if word lowercase, not in self word, following words. Here I will put the word in lowercase, and the default will be empty set. Okay. No. If it's not in that dictionary like this, I will use this dictionary, copy it here, and set the default value to the set, to the empty set. If the word is now in the following dictionary, so if it's not the last word, like the index is less than length of the split sentences -1, because in Python we are indexing from 0, colon. This is if the word is not the last, so I will store somewhere the following word is equal to no, sentences split into words, index +1 here, and update the dictionary. Following words, the key will be the word in lowercase, and I will add here the following word. Else, if it is the last word, I will add to the dictionary set of that word here, like lower. I will add there another symbol. I will like dot, for example. Now I can print also this dictionary, like print dot following dictionary there. To call this method, we need to call it like ChatGPT create the following words dictionary, and here put the sentences. Run the code, and there is a mistake somewhere. I see the mistake again. I a little bit type of, like this is the dictionary, not the method. Following words, and now it should be working. Yeah, first one is our word dictionary. This is the preceding word dictionary, and this is the words that are there appear after a certain word. For example, after I, there appear drink or love. After coffee, coffee is only the last word, so there is only that. Now it's time for generating the sentences. I will create the last method, generate sentence. Here will be the self and the length of the sentence. You can modify it by the parameter that you will put here. Close the terminal. I have a mistake somewhere. Yeah, I need to write here something. Okay, that's no problem. How we will generate the sentence? I will generate the sentence like, let me just run the code again. The sentence will be generated step by step. First step we will be generating the first word, then the middle of the word, and the last word. The first word will only be the word that was the first word somewhere here. The last word, vice versa. The last word will be only the word that appear as the last in any of these sentences. And for middle of the words, it will work like that the word can appear after a word if it also appeared in the training set, and we will choose the random one. The start word length will be 1, the end word length will be also 1. I will close the terminal. Here I will create generated sentence. This will be a list, and we will split that list in the end of this method. So here, and the length of the middle of the word length, like this, is equal to the length minus the start word length minus end word length. The word in the sentence can be also named a token, but doesn't matter right now. Here I will write some comments. Here I add the first token. Here I will add the middle of the word, and here I will add last token. Here return generate sentence. And to add the first and last token, it will be again very similar. I will create first token check. It is the first word, but I call it token for some reason here. First word check. It will contain the symbol of nothing before the first word, and here I need to get the keys from the dictionary. That means our words, and I will choose the random one. So keys from words from beginning words. I will do this with list comprehension. Get the key for key and its value set. So its value. We have a set of values. That's the reason I'm calling it value set in self, preceding words, all the items. If there is the condition, the first word first. If there is the symbol for the first word of the sentence. If the first word, check, like this symbol, is in the set of values. In value set. Here, the first word is equal to random choice from the keys. And I will append this first word to the generated sentence. First word. For the random, I need to import only one library. This import random. It will give us the random choice from this list of the first words. For the last token, it will be the similar. So last word check will be this symbol of the dot, keys from end word, list comprehension. I will get the key. For key I need value set in self dot dictionary following words, and items if the dot is in the value set like here, and the last word will be randomly generated last word, random choice from the keys of the end words, and the generated sentence append the last word. Now it's time for generating the middle of the word. It will be kinda similar, but we need the previous word. Previous word. For the second word, it will be the first word, because that will be the word before the second, while the length of the generated sentence is less than the middle of the word, +1, because there is the first word and the length of the middle of the word, and we need to have the same lengths. After the last iteration, these two will have the same length. So after this, I need to find the keys for next word. I need the key for key value set in self preceding words, items if previous word is in the set of previous words. If this apply, the next word is random word from the keys of the next words, and we will append this word to the final sentence. Next word, and the previous word will be the next word for the next iteration if it's needed or not. Now to print the sentence in the correct form, I will use this. I will join the word into the string from the list, like generated sentence. Here I will use the ChatGPT 6 generate sentences. Here the length I will use number 4. I will store it into the generated sentence variable and print the generated sentence. Run the call. Check if everything is okay or not. It is not. I have a mistake. Where is it? Where is it? I have a mistake. I see it already. There is not create, but preceding, like in the dictionary. Maybe this time, yeah. And our sentence this time is dogs do not coffee. It makes sense. You just do not, yeah. It don't make much sense, but our ChatGPT 6 is that intelligent that it can predict the future syntax of our language. Yeah, that's the reason why this sentence doesn't make sense. Jokes aside, our class generate simple sentences, but sometimes they do not make much sense, but don't worry. But the most important things we know now is that the words are represented in the chatbots by the dense vectors of the float numbers, and the core idea of that algorithms is it will take the numbers from the words around that certain word, and by these numbers it will somehow compute the semantic meaning of that word. That's all for this video. Make sure to hit the subscribe, like the video, and write something to your fellow programmers to the comment section. Have a beautiful rest of your day. Peace!